My name is Rob. If you want to reach out to me after the show and have any questions or whatever, these are the outlets where you can contact me. I'm also going to be selling T-shirts and CDs by the exit. So let's talk about ReactiveCocoa. Or rather, let's talk about how I stopped worrying about state and love FRP. And let's start with state. So I gotta say, I hate state. State is probably the worst thing there is in programming. It's probably even the root of all evil. And that's because state is hard. And I'm personally a very lazy guy, so I try to avoid all the hard things. And it's causing a lot of bugs, and I even have circumstantial evidence for that. You've probably heard this phrase before. Have you tried turning it off and on again? That's common advice for computer problems. And the bad thing about this piece of common advice is that it usually works. And that is because of state. Because if your phone is acting up or your computer, your Windows computer, is having problems, then the chances are that somebody got the state transitions wrong. But by power cycling it, as we call it in the industry, you can bring your program back to the initial state. And then state transitions close to that initial state are more likely to be correctly implemented, because those are the ones that come up all the time in testing. So in order to write good and hopefully bug-free programs, we as programmers should strive to minimize state and have as little of it as possible. I hope you cannot read that in the back. And this is nothing new at all, right? I'm probably preaching to the choir here. So if we look at an example, let's say you're tasked to implement a model object that looks a little something like this. You have two read-write properties, quacks like a duck and walks like a duck. And then there's a third property called probably a duck. And that's just a convenient accessor that returns yes if and only if quacks like a duck and walks like a duck also return yes. So I'd argue that nobody in this room would implement this in a way that in the setter for quacks like a duck and in the setter for walks like a duck, you modify the member variable for probably a duck, because that's just a lot of code to write and it's easy to get wrong and everything. You probably wouldn't do that. Instead, you'd rather write something like this, where in is probably a duck, you just derive that value, whether or not the object is potentially duck-like, by just ending the member variables for quacks like a duck and walks like a duck. But still, in order to be a good citizen of the operating system and obey the laws of KVO that Steve passed down to us, you still need to define key paths for values affecting probably a duck, say that 3 times fast, in which you return an NS set, which doesn't even have a literal, and then you return all the key paths that probably a duck is dependent upon, so that when walks like a duck changes, you also automatically get a KVO notification for probably a duck. And this is all right. I mean, it's not nice that we have to write 2 methods where we only are concerned with one thing. But I guess it's okay. But I guess I also wouldn't give this talk if I didn't have an alternative solution, right? So let's try and see what the ReactiveCocoa version would look like. So the ReactiveCocoa version, and let's not consider the details for a moment, but you can already see that I'm declaring a relationship here. I'm saying that self probably a duck is combining the latest values of walks like a duck and quacks like a duck and somehow reducing them to a single Boolean. I get the 2 NS numbers, get the bool values, end them, and return that. So you kind of can see what it does, even though there may be some question marks above your heads right now, but you got to take my word for it that this is functionally equivalent to what you just saw. And this is, I mean, this is more or less the same amount of code, but at least it's a bit more locale. So that's probably not too convincing. Why would you write this rather than the other one? Well, let's look at a more complicated example, or is it? So this is a super common use case, right? We've all done this a million times before. It's a newsletter app, in this case, and we want to have a nice-looking sign-up flow. And the idea is that if I only enter username, the sign-up button is still disabled, but as soon as I enter a valid email address, whatever that means, the sign-up button is enabled. And if you think about how you would implement that, it suddenly becomes a lot more complicated, right? There are technical things you have to consider, even though the example is pretty much like the one we saw before. We just derive the enabledness of the button from the validity of the email address and the username, but suddenly the conventional code looks like this, and it's like you have to add a target and a selector, and there's UI control event editing change notifications going around, or you have to add a target rather. Or imagine this would be KVO based, right? And it's even more annoying. But if we look at the, right, and not only is this more annoying, this is also hard to communicate to outside people, right? How often have we been tasked to implement something and then the requirements suddenly changed in a way that the code become much more complicated, but outside people, like not programmers, they don't necessarily understand why that is. I mean, we know why. The answer is because programming, duh. But it really shouldn't have to be this way. But if we look at the ReactiveCocoa version, it still looks pretty much the same, right? Nothing has changed. I added some email validation logic and username validation logic down at the bottom, but it's pretty much still the same thing. So what's going on here? What we see here in action is FRP, which stands for Functional Reactive Programming. And it's a programming paradigm that tries to model applications with values that are derived from other values and that change over time. And by deriving them, instead of like having callbacks that modify variables, you minimize state and therefore hopefully also bugs. And this is the slide you've all been waiting for. Microsoft, not too long ago, released a library for C# called Reactive Extensions, or RX for short. And that's probably the first mainstream implementation that brought functional reactive programming to an imperative language like C#. And in these modern times, I mean, there's a huge influx from Ruby programmers in the Objective-C community right now. That we have CocoaPods and things like that. So it's really a good opportunity to learn from other programming languages and from other programming paradigms. So the nice people at GitHub, for their Mac application, wrote a library that uses a different terminology from RX, but still brings the same fundamental concepts of functional reactive programming to the Objective-C world, and that is ReactiveCocoa. And note that it's ReactiveCocoa, it's not functional ReactiveCocoa, so it's very pragmatic. They know that you're running iOS apps and that Objective-C is not pure, and you're probably going to have side effects and everything, and you may not know what lambda calculus is and everything, so it's really still Objective-C and it's still Cocoa. There's nothing to be afraid of. And if you want to know more about it, well, there's really only two things you have to know, two core components. The first one is RACSignal. And a RACSignal is that thing that models that value that changes over time. So you can think of it as an emitter of values. And those values could be pretty much any object, right? It could be Booleans, or it could be UI control event editing change things wrapped in an NS number. But it could also be data that you obtain from a web service. So it could be pretty much any object. But on the other end of that arrow, of course, there's something, and that's the RAC subscriber. And whenever a new value arrives over the signal, one of three methods on the RAC subscriber is being triggered. The first one, and probably the most important one, is send next. So every time there's a new value, send next is going to get called. So yes, no, yes would be the parameters sent to that method. And that may actually never happen. So you could have a signal that only completes, right? Complete is the next thing. Complete means no more values are going to be sent. You're free to free up all the resources you have allocated for observing the signal. But because nothing is ever nice in this world, there's also send error, which also means that no more values are going to get sent. But there's an error object that's communicating out of band what went wrong and how you can react to it. And all of these methods are optional. So you can have a signal that never completes, or you hopefully can have a signal that never errors, or you can have a signal that never sends anything. And you're probably like, so what? What's the big point of that? Why would we treat variables like streams rather than just variables? What's so wrong about that? Well, the thing is, once you model the behavior application with streams, you get access to a very powerful toolset that you may already be familiar with. Because streams, they are easy to deal with, right? You can map streams, you can reduce streams, you can filter streams, you can concatenate streams. That's all suddenly very, very easy. So think about map, right? If you want to map a signal, you would subscribe to one signal, apply transformation, and send the new value out on another signal. Reduce, that's the one we saw earlier. You subscribe to a bunch of signals, reduce all the values to a single new one, and send it out again. Filter, you just look at the values coming in, and if you like them or not, you send them on. So that's easy, and it's obviously, that's kind of nice for UI interactions, but there's more to it. So let's talk about asynchrony. And if we talk about asynchrony, we have to talk about this fella. Asynchrony usually means waiting for something. And the iPhone is never really fast enough. That's why there's a new one every year. And internet is never fast enough. That's why telecom is doing whatever it's doing right now. And more often than not, you're waiting for something. And when you wait for something, it's better, or it's actually best practice, to not block the UI. Otherwise, the spinner would stop spinning, and that would be horrible, right? So instead you want to model your application so whenever the result is there, wherever it came from, you get notified. And back in the day, we had to use these obscenely long protocols that we had to implement with all the callbacks, and then we got blocks. And blocks are awesome. Everybody loves blocks, right? And nobody wants to go back to the old days. But still, blocks kind of brought a new set of problems along with them. And one is that there's no clear convention like what blocks should look like. If you have an asynchronous operation, there may be one block for the success callback, there may be one block for the error callback, or there may be a single callback, but then where's the error? Maybe it's the first argument, maybe it's the last argument, is it optional, yada yada. There are a lot of specifics there. And another issue, and that's probably a more common pain point for you, is callback hell, right? If you want to put a lot of asynchronous operations in a sequence, then, well, in this case, I just want to get my newsletters. But in order to get my newsletters, well, first I have to load the me user. And in order to get the me user, I have to log in. So you can see that all these failure blocks are piling up on the bottom. That's not really nice looking, and it's complicated. And honestly, Objective-C lines are already long enough, so I don't need to have all that indentation. So there's probably a better way to do it. And we already saw that RACSignal can model data from a web server that may or may not arrive in the future. So how can we refactor our code using RACSignal to achieve the same thing? Well, the first thing that we would do, at least that's what I'm proposing right here, is that we refactor our client a little something like this. So every interaction with the API would return a RACSignal that models the state of that interaction. So in this case, login would return a signal that completes if the event, if the login was successful, or it would send an error if it wasn't. To load me user, that signal would send a user and then hopefully complete. Otherwise, it would send an error. And load newsletters for user would give the user return a signal that sends all the newsletters that the user subscribed to in an array and then complete. And here you can already see one of the shortcomings with React and Objective-C, in that there's no way for the compiler to assist you what's happening with the signal, right? In a language like C# or Java, you would have parameterized types, and the compiler could make sure that when you subscribe to load me user, that the block you pass in actually has a user as its argument type. So when you use ReactiveCocoa, you have to always clearly communicate what's going on, what's happening over the signal, which I think is a good practice anyways. So now that we have that in place, let's revisit our example, right? So this already looks a lot nicer. So what's going on here? In the first line, I'm calling the login signal, and if that completes, I call sequence next to sequentialize a new signal, right? If you think about it as streams, having one stream and then the other stream, it's just concatenating. That's easy. A bit more complicated is the next clause, the flatten map. Here, I take the value that's hopefully coming in from the signal we created above by combining the other two, and that signal returns a single user. And with that user, I inject a new signal into the stream that I obtained by calling load newsletters for user from the API client. And now I have composed a single signal that does all the things for me. It logs in, it loads the me user, and it obtains my newsletters all in a single signal. And all the state that I would have to handle normally is abstracted behind that. And you can see that now that I have this signal, there's only one subscribe and one error clause. So all the error handling can be done down on the bottom, but we hope it doesn't come to that. Instead, we would pass in a block to subscribe next that it's called whenever the newsletters arrive. So this is much easier. And it's great for API interactions. But there's another added benefit, because once you model your API interactions and your user interactions in a similar fashion, you get access to powerful ways to compose the two. And if you think about it, that's really much that's really everything a lot of apps do, right? The user touches something on the screen, and somewhere in the cloud a bit flips. So let's revisit our example. And now we want to change the requirements a little bit and say that the email address is not validated locally anymore. It's going to be validated in the cloud. Like, think about how you would implement that. You would have to, first of all, you would have to make sure that only if the email address changes, you check whether or not there's a connection already running, and then you would have to cancel that and send a new connection and everything. And the example gets even more complicated, but it doesn't really have to, right? So how could we do it with RACSignal? Well, first we would add to our API client a method called validate email that returns a new RACSignal that sends a yes or no Boolean, or NS number rather, over the signal whether or not the email was successful, the email was valid. And now that we have that, we can refactor what we saw earlier and extract the validation of the email into its own signal. And this potentially may blow your mind. I like to apologize in advance. But what's going on here? So we take the text signal that is that RAC offers us as a convenient way to deal with UI text fields, and that sends whenever the contents of the text field changes, it sends a new string over the signal. So if I enter my email address, it would be R, RO, ROB, ROBB, and so forth. And on that signal, we call map and apply a mapping. And here, we take that email address and return a new signal. And the tricky part here is that when the email changes, we immediately want to disable the button, right? You don't want to have it so that I enter a correct email address, and then I could kind of have a timing attack where I quickly enter an invalid email address and hit sign up. We don't want that. So we prepend that with no. So if I enter an email address, a new one, that signal that we return sends no, and then it does its calculations, and that may take whatever amount of time, and then it would send a new value. So actually 2 values are going to get sent over that signal. And then we return that in the map clause over there. And if you paid attention, hopefully you did, then you notice that we now have a signal that returns a signal. And this is where the magic happens. So by calling switch to latest on the signal of signals, what we say here is that we only ever are interested in values from the latest signal. So if I enter a new email address and I'm already subscribed to an old signal, behind the scenes, switch to latest would unsubscribe from the old signal, hopefully also cancel the network request in the process, subscribe to the new signal, and give me those values. And the rest of the example still hasn't changed a bit, right? It's still the same stuff that we saw earlier. Complexity has not gone through the roof just because we did something on the server. So I think this is a really powerful way. And if we look at it, it actually works, right? Sign up button, still disabled. It's not a real app. So where's the catch? Well, you probably already saw that there's quite a bit of conceptual overhead. ReactiveCocoa definitely takes some wrapping your head around. If you've done functional programming before, some of these things may have been familiar to you. If you haven't done any functional programming, it's highly recommended. Like, you should never be afraid to investigate new paradigms and new approaches to software, right? Another kind of tricky thing about this is debugging, because signals are usually composed of other signals that are made of other signals, and it's signals all the way down until you hit turtles. So you have to kind of apply new techniques when debugging. So one very handy method is log all, that just logs all the things that go over a certain signal to the console, so you can kind of keep track of what's going on. There's also ways to give signals more meaningful names. So instead of map, map, reduce, map, map, you could call it user creation or whatever, and then log all returns even more meaningful information. And another thing about ReactiveCocoa is that it really forces you to think. And that may be a good thing, depending on how lazy you are, but you really have to think about what is it that I'm trying to achieve? What is the desired output? And how can I derive that from what's coming in? So I guess the last remaining question is, should you use it? And my answer is definitely probably. You should definitely play around with it. You don't have to go all in, so you could try and model your sign-up flow with ReactiveCocoa, see how you like it. You already kind of saw how that works, so it's really easy. And even if you decide that it's not for you, do me a favor and keep trying minimizing state. I'm afraid I finished early. Never happened to me before.
Hi, Rob.
Hi.
What I'm doing in an app is something similar. I have an auto-completion there, like when you typed your email address and it validates on every keystroke. How hard would it be to insert a delay in there? Because what I'm doing with my auto-completion is I wait for 0.4 seconds with a...
So in that particular case, there's a very handy method called throttle that makes sure that events are not sent faster than whatever amount of time you put into. So in order to conserve network requests, I guess.
Exactly.
But I guess even if you could do that, or you could also just make use of the automatic cancellation of the network requests and save bandwidth that way. But yeah, once you have streams, there's a huge amount of helpful methods like throttle, for instance, that you can use. And that's very easy just by changing the approach.
Okay, cool.
Hi. I was just wondering if there are like alternative implementations of the reactive programming pattern for Objective-C, or is there only ReactiveCocoa for now?
I'm only aware of ReactiveCocoa, but you can achieve like a subset of the functionality with different libraries. So if you think about just the API interaction, you can also use promises, if you're familiar with that. So that's kind of a subset of that specific functionality. You can also write a lot of code and use KVO for another subset of the functionality. It's also a bit similar to bindings that we have on the Mac. So it's nothing radically new. It's just a lot of, it's just a neat package, really. But I'm not aware of any other implementations.
Thanks.
If you use Xamarin, I guess you can use RX.
Hi. I also played around a bit with ReactiveCocoa, and I stumbled across a problem that I do a lot of concurrency stuff, and then I have to specify, okay, I want to have this block executed on this queue because I have state.
Yes.
I'm sorry, but at least at some point I need state.
So,
and is there some built-in thing to dispatch something on a queue? And
so the question is, how can you enforce access on a certain queue? And there is actually something like that. There's a handy method called deliver on. So the classic example is you have a computation that runs on whatever thread, but you need to make sure that you only access the result of that on the main thread, because you want to stuff it in your UI, and that's what you need to do. And then you would take that signal, and ideally as late as possible in the chain, you would call deliver on and pass in the scheduler that represents the main queue, and that would make sure that events are only delivered to you on the main queue. And then you can update your UI safely without having to worry about that.
Do you actually subclass RACSignal, or do you always use a base class?
You wouldn't necessarily subclass RACSignal. So there's a method called createSignal, where you pass in a block, and you get a link to the subscriber. So you would call the subscriber directly, and you would return in that block a disposable, and that disposable is a hook for you to know when nobody's listening anymore. So if you have a network connection, you would, in the block that you pass to the disposable, you would cancel your network operation. There's also other ways to create signals, but subclassing isn't really the right approach for most use cases, I guess. Cool, thank you.